In this question, a single phase full controlled thyristor converter bridge is used for the regenerative braking. The rated armature voltage, rated armature current, rated speed is given, armature resistance is given, the input to the converter bridge is given. The armature of the DC motor is fed from the full control bridge and the field current is kept constant. Assume that the motor is running at the 600 RPM. So see, what is given this question? The rating of the motor is given. The rated armature voltage is given V. In the rated condition, the armature voltage is nothing but the 210 volt. Armature current rated value is given, that is the 10 ampere, and the armature resistance is a 1 ohm, it is given. Now the rated speed is 1200 rpm, n rated, that means in the rated condition it will run at the 1200 rpm speed. The input to the converter bridge, that means the supply voltage is the 240 volt and the 50 hertz. 240 volt, the given voltage would always be the RMS voltage. Assume that the motor is running at the 600 rpm. When the motor is running at the 600 rpm, N is a 600 rpm. When the motor was running at the 600 rpm, then regenerative braking is applied. When we apply the regenerative braking, then the polarity of E must be reverse. The polarity will be reverse here. Then find out the value of alpha. Now come to its solution. Single phase half bridge inverter is there. So I have a motor. This is the armature circuit of a motor. It is fed by a single phase bridge inverter, single phase, and this is a 240 volt. The RA is 1 ohm. In the normal condition, this is the polarity of induced EMF. So in rated condition, let's find out in rated condition how many the EMF will be induced. In rated condition, the induced EMF in the motor is, we can find out by V equivalent to EA plus IARA. The rated voltage is a 210 volt. That is the induced EMF in the armature. Rated current is a 10 and RA is a 1. So in the rated condition, the induced EMF in the armature is equivalent to 200 at 1000 or the 1200 rpm, because the motor is running at the 1200 rpm in the rated condition. But we are applying the regenerative braking when the motor was running at the 600 rpm. We all know that the induced EMF is depend upon the flux and speed, but the field current is constant, that means the flux is constant. The field current is constant. It is a separately excited motor. The field current is creating the magnetic flux, so the flux is equivalent to constant. So we all know that the induced EMF is equivalent to the K phi into omega, or you can say the K phi. Omega is nothing but the 2 pi n upon 60 in term of RPM. N is the RPM, omega is the radian per second on 60. So induced EMF is proportional to the flux and the speed. But we all know that the flux is a constant. As the flux is constant, so the EA is directly proportional to the speed only. So in the rated condition, if the induced EMF is a EA rated, in the rated condition it is running at the 1200 rpm. So when the motor was running at the 600 rpm, that what is the induced EMF at that time, that in the motor. So induced EMF at that time is become, this was the 200. We find out na 200. We do not find out. Yes, 200. EA rated was the 200. This is my rated EA. In the rated condition, the induced EMF is equal to 200. Now, when the motor is running at 600 rpm, at that moment, the induced EMF is the 100 volt. At this time, we have applied the regenerative braking. So when we apply the regenerative braking, we change the polarity. So the polarity of induced EMF will be changed here. The RA will remain same, but the induced EMF polarity will be reversed. It is become minus and plus. Now it is coming through a single phase full bridge converter. So now what is the voltage here? So the voltage V across the armature is become minus E plus IaRa. That is the voltage across armature during regenerative braking. During regenerative braking. Regenerative braking. So regenerative braking, the V is minus 100 plus 10 into 1, that is the minus 90. Minus 90. And we all know that the V is nothing but, this V is nothing but the output of converter. So V, that is the minus 90, is the 2 Vm upon pi into cos alpha. By changing the value of alpha, I can get the value of minus 90 here. So minus 90, Vm is the RMS value multiplied by root 2 upon pi into cos alpha. Just find out the value of alpha, you will get the alpha is 114 degree. 114 is the right option. So 114 is the right option. Is the right option.